We're excited to have you join us today for our weekly OCI deep dive on recent product releases and updates. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, our Oracle community forum for end users. Today, we're joined by Melliyal and Annamalai, Distinguished Product Manager of OCI, who will take us through a deep dive for Oracle Autonomous Database Graph Studio, a self-service tool that automates and simplifies modeling and visualizing graphs across a data lifecycle.
Thank you very much, Esther. And hello, everyone. It's great to be here. Thank you for joining us. And it's great to spend this hour with you talking about graphs. I did see from the polls that you are familiar with graphs and you are seriously considering graphs analytics in your organization. So maybe I could go maybe a little faster than I had originally planned through some of the initial slides and spend more time on some of the technical aspects of the Graph Studio feature of Autonomous Database. Let me first introduce myself. I'm Melliyal Annamalai, Product Manager with the database organization. I have over 20 years of experience working with unstructured and semi-structured data management. I've worked with a bunch of different technologies, multimedia, medical images, big data, Apache Kafka, and now I'm focused on graph and spatial technologies. So with that, let me get started. So if you're exploring graph analytics, I think you know a little bit about graphs. And basically, graphs are a way to analyze your data based on the connections and relationships between data entities in your data. And this gives you new insights which are not easily possible using some other technologies. So what graphs enable you to do is to make explicit relationships that are implicit in your data. And the first example that people think about when it comes to graph analytics is often social network analysis. Because when you think of social media and you think of people reposting other people's posts, or you think of people following other people, these are intuitively relationships in your data that you can model very easily as a graph to find out things like who are key influencers in a social network and so on. So what I want to focus on today, and I hope you will leave with at the end of the session, is how enterprises can make use of graph technology for all kinds of new insights. So I want to start with looking at various customers, how they're using graphs, and then talk a little bit about the technology itself. So the graphs can just be considered as a different way of looking at your data. So when you model your data as tables and columns in a database, which is probably where most of your business data is, the relationships are more implicit. Like there could be a foreign key relationship between tables, or your application could be running join operations on tables, and that's where you're kind of connecting two different tables. When you model your data as a graph, you are able to explicitly model these relationships. So you can run graph algorithms from graph theory, things like community detection algorithms, things like clustering algorithms, algorithms that identify which are important vertices, and so on. And we'll be looking at several examples in this session. And also it gives you the ability to run pattern queries on my graph, like is there a cycle in this graph? A cycle is a pattern. Or is there some other pattern that I can represent in my query? And does that pattern exist in this graph? And again, we'll be looking at some more examples. So modeling your data as a graph helps you run such graph pattern queries and graph analytics algorithms on your graph. So here's an example which would be similar to what an enterprise would have. For example, you might have a table of customers, a table of movies, and the relationship between them is that a customer has rented a movie. And this, incidentally, is an example we have in some of our demos. So the relationship here between customer and movie is the fact that a customer has rented a movie. And that's the relationship that is captured in the cost sales table. And when you model your data as a graph, that can become an edge in your graph. So your customers are all vertices, which means every row in your customer table will become a vertex in the graph. Every row in the movie table becomes a vertex in the graph. So you have two different types of vertices. And then for every relationship of customer renting a movie, you add an edge to the graph. And when you do that, you get what is called as a bipartite graph, because you have two different types of vertices, and the edges are only between these two vertices. And when you these two sets of vertices, and when you have such a graph, you can apply many different algorithms. For example, the whom to follow algorithm, which will cluster the customers based on the similarities in the movies they have watched. So if customers have watched similar movies, they would belong to a community, and you can use that to make recommendations to those customers based on what movies others in the community have watched. So you can see here that we're taking the edge relationship between vertices, applying this graph algorithm, and getting some recommendations into what movies we can recommend for a particular customer. Another example here is, let's say, a set of financial transactions. You have a bank accounts table, which is a set of bank accounts, and bank transactions, which indicate that there has been a cash transaction between two accounts. When you model this as a graph, every bank account can become a vertex in the graph, and every time there's a transaction between two vertices, that is an edge in the graph. So when you model your data like this, you can then start narrowing down into which are the accounts that have a high number of transactions flowing through them. And even if they don't have a high number of transactions flowing through them, perhaps they're connected to other accounts which have a high number of transactions flowing through them. And that's what something like the PageRank algorithm helps you do. It recursively goes through the graph and assigns a PageRank value to every vertex in the graph, which denotes how connected that particular vertex is. In this case, accounts, how connected that account is. And that is measured not just by looking at the number of incoming or outgoing edges, it's also looking to see whether a particular vertex is connected to other vertices which have a high PageRank value. In other words, when you're looking at importance of something, it's not how many people you know, but it's who you know that determines whether a particular vertex is important. So you can see here that gives you more subtle insights into which accounts are involved in a lot of cash transactions, which has a number of uses, as we will see when we start looking at some of the customer examples. It's not just Oracle graph, and it's not just we are saying that graphs are cool and graphs can really get new insights in your data. Folks like Gartner have repeatedly identified graph databases as an emerging market. It's one of their top 10 trends, and they're seeing customers really wanting to relate data, and that's what graphs enables you to do, right? Relate different entities. And that is something that is a growing topic of interest. So with that, let me move on to some of our enterprise customers so we can see how they're working with graphs. So PaySafe is a payment solutions provider focused on the gaming industry. And they have certain limits on what folks can do on their site. For example, they have certain limits on the amount of money that can be transferred between two accounts. So when they want to detect folks that are using the system fraudulently or breaking the rules, they would have all of these long meetings where they would look at all the transactions and try to understand what is going on. When they had the little epiphany that this is really a graph, they said, oh, what we're looking at, how money moves, is really a graph. And once we represent our data as a graph, we can then very quickly hone in on which are the accounts that we need to investigate further. So here's an example that, or the screenshot, a visual they shared with us. So here on the left, you see two vertices, a source vertex or a source account and a destination account, and lots of cash transactions happening between them, but going through lots of intermediate accounts. So to them, in their business, this is something they wanted to flag because perhaps the source account is trying to hide the amount of money that's being transferred to the destination account by using several intermediary accounts. And on the right, again, there are lots of accounts, but relatively few source and destination accounts. Lots of them are just intermediary accounts. And that's something when they model the data as a graph and do things like path analysis to say, okay, here are all the paths that are connecting this account with this account. Such path analysis makes it instantly obvious as to what's happening, like how is money flowing from this account to this account. So graphs have been really useful for them with that. Another customer, CaixaBank, as part of their digital innovation transformation, they wanted a better way to identify customers who belong to the same, who are similar to each other, because they wanted to really provide a better customer experience for their customers. So they model the customer interactions as a graph for some very interesting results. So what they do is, that this is one of the things that they do. They use graphs in a variety of cases. So some of the things that they shared with us in public webcasts and so on is that one way to identify customers who are similar to each other is the fact that, okay, they live in the same address. So they're probably family, or the other ways of identifying they belong to a community. But what they were doing here is, if they see two customers use the credit cards at the same time and place within a few minutes of each other, perhaps it's two colleagues or two friends having lunch. So maybe there should be an edge between them because there is some kind of connection between them. And then they build up their graph this way, and then they run a community detection algorithm on the graph to identify subgraphs within the larger graph where the vertices are tightly connected to each other. Graph analytics algorithms, there are many of them to identify such communities within a larger graph. And once they identify these communities, these are customers who have similar interests, similar incomes, and perhaps would like to buy similar products. So they're able to better market their products, other products to them. So graphs have been transformational in identifying and kind of doing customer 360 analysis. And they've also customized some of the community detection algorithms, as you'll see a little later. Oracle Graph includes over 60 pre-built algorithms. And also we give customers the ability to customize them. So they have some special customizations that they've done in their community detection algorithms. And their graph is very large. They have over 400 million vertices and 2 billion edges, and they're able to use the graph for real-time transaction monitoring because of extremely good performance times. So a couple more examples from different domains. Graphs are used by one of our partners in modeling security hierarchies. So whether someone has access to a particular document depends on which group they're in. And sometimes you're inheriting security privileges from a different group. You might inherit security privileges from multiple groups. So you could very rapidly have a complex set of hierarchies to model the security privileges in an organization. And this partner is in the business of helping customers manage their data. And in spite of being a small startup, because of some of the tools that we provided, they were able to very easily manage their security nested hierarchies as a graph and quickly provide value to their customers. Another interesting partner is SPITS. PITSS. What they're doing is they take legacy applications and modernize them. So when they evaluate a legacy application, they want to identify the different modules. They want to identify how data flows through these different modules. And they want to identify whether data flows through some modules repeatedly and so on. And they found that by modeling this as a graph, different modules as vertices and how data flows as edges in the graph, they're able to really cut down the time of analyzing legacy software, like from days to like half to a few hours. So you can see that graphs have many different applications in many different industries and many different use cases. And my last customer example, I think, is in manufacturing. So cars and phones are very sophisticated products with a lot of different parts. So the bill of materials can be modeled as a graph, which shows how the different components are related to each other. It's useful for managing your inventory, determining what products you can make today, and also determining the financial impact of when the design of one particular component is changed. You can, by doing again path analysis, you can see all the components reachable from this particular component that you're evaluating, and that gives you all the components connected to this component. So modeling your data as a graph, again, once again, simplifies applications here. And okay, one more example, with this is managing product catalog, once again at CaixaBank. So graphs are also used to represent, useful in representing data with a flexible schema, where you don't have the same number of attributes for each data entity. And in particular, the RDF graph model is used for these type of applications. So there are two types of graph models: the property graph model that's used in analytics, and that relates to all the examples I was just talking about. And then you have the RDF graph data model, which links data from multiple sources, allows you to represent data in a flexible way so that your data and rules about the data are in the data itself and not in application code. And I'll show more examples to see, to illustrate how RDF graphs are used. So CaixaBank uses this to manage their product catalog information. So to kind of summarize some of the business problems that we can solve, you can identify customers to see, do they form a cluster based on activities that they perform together? What new relationships can be identified from existing connections by doing path analysis? Looking at a cycle in a graph as money moving around in a cycle, that could denote money laundering. And one of a telecommunications customer uses graphs for doing what if analysis, modeling the network as a graph. And if a network node goes down, they can identify all the network nodes that are connected to that particular node and so on. So let me now go into the property graph feature overview. So the Graph Studio feature of autonomous database. So, and if you have, if you're using autonomous database, you have access to Graph Studio. That has several interesting features. It includes a in-memory graph server. Like some of the graph operations can be compute intensive. So we have this specialized graph server that runs in memory that enables extremely fast graph analytics and graph queries. So in your autonomous database, you can create your graph, which can be like a property graph view on your database tables. You can load this graph into this in-memory graph server, and then you can run analytics on it. And all of this is in a managed environment. And then when you run graph, when you want to query your graph, you need a query language. And that's the property graph query language, which is a SQL-like language, because you need the ability to specify graph patterns. I'll show some examples of that and the standards activities that are going on there. And also we have over 60 pre-built graph algorithms, like I referred to PageRank, I referred to community detection algorithms. All of these are available out of the box that you can call from your Java or Python application. And Graph Studio includes an advanced notebook with integrated visualization where you can run some of these algorithms and then query the results. So that's a quick example of some of the what we mean by the property graph query language. When we say it's SQL-like, it means, we have the select, the from, and the where clause and constructs like that. In addition, it includes a match clause. And the match clause gives you the ability to specify the graph pattern. So what's happening here is we're saying on the top left here, we're saying select any edges in the graph. So anything in parentheses is a vertex, anything in square brackets is an edge. So we are saying find me all edges in the graph. It's something like saying select star from tab. And here on the bottom left, we are again selecting edges from this graph, but we're qualifying the vertices and the edges. We're saying I want edges where an edge starts with a vertex of type person, and the edge itself should be of type transfer. So you're qualifying the type of vertex and the type of edge. And on the top right here, you're specifying a pattern. In this case, it's a 3-hop cycle. So A connects to B, B connects to C, and C connects back to A. And that is a 3-hop cycle. So I want to see whether there are 3-hop cycles in this graph. And in the last example here, we are saying I want to match, I want to find all paths of type transfer starting with the vertex of type person, and I'm qualifying that with this where clause here where in name equals Nikita, and I'm saying that find me any path that's 0 or many hops long. And all of this is very similar to the ISO standard that is expected to be published this year. The SQL Standards Committee, the ISO body, and Oracle is a participant of that, has been working on extending the SQL language to work with graphs. We have aligned the syntax of the property graph query language to that emerging standard because still that standard is available. The property graph query language is one way to query your graphs. And here are some examples of the over 60 algorithms that I was talking about. We have different categories here. The ability to detect communities here. So you have many different kinds of community detection algorithms. Ranking and walking is to find out important nodes in a graph. PageRank is by far the most popular. And there are other examples of the vertex between the centrality will actually find out whether it find out the vertices through which many of the shortest paths in a graph flow. In other words, if you remove that particular vertex, your graph might become disconnected, and several different path finding algorithms, and also very importantly, machine learning algorithms. Graphs and machine learning is becoming a very hot topic. The ability to use graphs with your machine learning algorithms, and also there are graph algorithms that include machine learning concepts, as in include traversing your graph as you go from layer to layer in a CNN network, for example. So we support some of those algorithms as well. So with that, now let me switch to a demo of Graph Studio so we can look and see how some of these things work. Let me pause my sharing here and switch over to my browser here. So this is, if you're familiar with Autonomous Database Console, this is your Autonomous Database Console, and right here on under the Tools tab, you would see Graph Studio. So you can open Graph Studio, and I've already logged into Graph Studio here, so let me go over here. So when you log into Graph Studio, you get to a console that looks like this. And one of the key features is the automated modeling we have for creating a graph. Because when you have your table, I said you can create a graph that is a graph view of your data. So that means you have to identify which are the edges in your graph, which are the vertices in your graph, and then say, I want to create this graph view. And the automated modeler can automate that. It looks at the primary key information, it looks at the foreign key relationships that you may have in your table, and comes up with a graph definition that you can then decide whether you like that or not. So if I want to start modeling my graph here, and here I'm using the bank accounts example, where I have the bank accounts table and the bank transactions table. So I would select these two tables. And here I see here the graph type is PG view. So this means the data is not moving anywhere. The data is staying right in the original tables. You don't have to move it out of the database. You don't even have to move it to a different schema. You can create a PG view of your graph right in that schema. So then I click on next. The modeler now gets to work and identifies the vertex tables, the edge tables, and what the graph definition should be. So you see here it has correctly identified the vertex tables as bank accounts, the edge tables as bank transactions. I can take a look at the source here, and this would be the create property graph statement that I would have handcrafted if I were to do this manually. But now I can look at this to make sure that everything is as it should be. I can look at the source key and the destination key, and if I decide I want to reverse the edges there, because I want the source key to be the from account ID and the destination key to be the to account ID, I can go back to the designer here. I can select the edge table, and then I can flip the direction of the edges. So I flip the direction of the edges, that will update the source statement, and then I can go ahead and click next. And then once I have everything in place, I can go ahead and create a graph, and it'll ask me to give it a graph name, and I can go ahead and create a graph. Now I already have created a graph, so I'm going to show you the graph that I have created here. And you can see here that this is a graph, and I also have two graph types. Like I said, we have the property graph type, we have the RDF graph type, and this is the property graph type. So I'm interested in property graphs. And if you want to do some analytics, I can go ahead and load this graph into memory. So while that is loading into memory, and loading into memory is loading into the specialized graph server that I was talking about, that helps you run graph analytics and graph queries in parallel at extremely high speeds. So while this loading, we can get started with looking at the notebooks here. So we have this integrated notebook environment that basically shows that you can use to run queries on. So you have a bunch of interpreters that can be used here. Like there is an interpreter where I can run PGQL queries in the database. I can run SQL queries on the database. I can run Sparkle queries for RDF graphs, and I'll show an example of that. I can run PGQL queries against the graph server. And then I can run snippets of Java code. I can run snippets of Python code to do graph analytics. So here's an example of a PGQL query where I'm basically saying select star from tab. Basically, I'm just saying select edges on the graph. Let me just go and see whether the graph is in memory. Whether that, yes, okay. So let me see whether I can go ahead and run this here. So I'm basically saying, and I'm only selecting 50 rows here. So I'm selecting I'm selecting about 50 edges from this graph, and I have different ways of visualizing the vertices and edges on the graph. This is a concentric visualization. I can change the visualization to something else. I can say that I just want a random way of visualizing the graph, and that shows some of the vertices here, or I can do different kinds of different ways of visualizing the graph. So depending on what you're looking to do, a particular way of visualizing the graph would make sense. So, and then if I want to start looking at frauds, I have these bank transactions, and I want to see how I'm going to identify more information about the graph here. So here I have I'm running a PGQL query where I'm just counting the in degree and out degree vertices. And that's the simple, and I'm going to run a page rank algorithm shortly, but this is just doing in degree and out degree vertices, and which means these are the accounts which have a high number of incoming and outgoing transactions. So I see here 934, it's interesting. I want to see whether 934 is part of a 5-hop cycle. So I'm starting here with A, and 0, I'm going up to 0 or 5 hops, I'm coming back to A. So I want to see whether there are cycles in the graph that are 0 to 5 hops long that start with account ID 934, because something here about 934 tells me I have to investigate this closely. So I can look at this, and I don't need to run every query here, I think. So so now I can say that, yes, indeed, there are paths which, there are cycles, I should say, which start and end with 934. And if I want to look at the last vertex or last account that is depositing money back into 934, I could explicitly list that edge here. So now I'm saying start with 934, have about 4 hops, and then explicitly list the last hop, which gives me a graph that looks something like this. So you can see here that I can keep exploring the graph, digging into what's happening here, how money is flowing. I can right-click at any point to look at some additional information about these edges and vertices and so on. And here, this is an example of a query that runs, it's actually looking for a 5-hop cycle. Again, it starts with A and goes to A, and I'm explicitly listing all the edges. I'm not just saying 0 to 5 hops. I want to say, okay, get me all the 5-hop cycles. And here, this is 934, and this is just one view. There are different ways of viewing the graph. You can see here that, yeah, this is 934, and then there are different ways of, this is a different visual of the graph. You can get all the loops that you have in the graph. Oops. And so on. So you can see here I can run different queries. Now I'm going to go and look at this PageRank example. So here is an example of running the PageRank algorithm, and you can see here is just a simple API call. I am just running PageRank on a graph that I've loaded into memory. And what happens here is it iteratively went through all the vertices in the graph and computed a PageRank value for each one of them. And once I do that, I can then use that in a graph, and I use that for visualizing a graph as well. So here I'm going to say, start with account ID 934 once again, where account ID is 934. But instead of looking at loops, I'm just going to look at paths which are 1 to 6 hops long. So I can run such a query, and that will give me the all the hops coming from 934. And also what I've done here is I've used some of the visualization features here. For example, here I have a highlight, which says that when a vertex has a particular PageRank value, color it differently. Give it a larger circle and color it red. And because I have that highlight, I can visually see that these are the vertices that have a high PageRank value. So I have 934, that's an account I'm looking at. I also find these other accounts that 934 is connected to that also have a high PageRank value. So if I'm looking for fraud, if I feel that 934 is doing something fraudulent, I'm interested in looking at other accounts that have a high PageRank value that are connected to 934 as well. So that's an example of running an algorithm. And then you can see here that I can query accounts and the PageRank values that they have. Here I'm querying accounts and the in degree and out degree values that they have, so not PageRank value. And when we compare the lists, I can see that when I go over to the second page here, there are some accounts here like 222 and 4 that have a high PageRank value, but don't have a high in degree or out degree value. And that's where the PageRank measure is a more sophisticated way of determining whether a vertex has an account has a high number of transactions flowing through it, or is connected to another account that has a high number of transactions flowing through it. So here you can see that this account 222 is indeed connected to lots of other accounts with high PageRank values. So these are just examples of different notebook paragraphs for running graph queries and graph analytics. I'll end here with showing you a RDF query, and I'm going to switch back to the slides and talk a little bit about RDF. And RDF is a graph model that has been a W3C standard for the last 15 years. And that has a Sparkle query language. It's used for a different set of use cases, and I'll come to that in a second. But using the same Graph Studio notebook, you can run a Sparkle query as well. So here's an example of what a Sparkle query looks like. So it's different. So for the property graph queries, you use the property graph query language. For the RDF graphs, you use the Sparkle query language. Here's an example of the Sparkle query language that you can run in this paragraph, and then you can get the results for a Sparkle query as well. So the Graph Studio notebook is very versatile. You can run property graph queries, you can run RDF graph queries, you can run SQL queries, all from the same notebook. So with that, now let me just go back to my slides to just talk a little bit about property graphs. Let me go back to my slides here. Okay. So back to my slides. So the RDF graph feature. So RDF graphs started off as a way, one of the use cases was to capture domain expertise about a particular domain. For example, if you're going to the movie example, like we were looking at the customers and the types of movies they rent, movies also have different categories, like you have a romance genre, which could include romance movies, romantic dramas, romantic comedies, and so on. And some movies, like a romantic comedy, could belong both to the genre romance and also genre comedy, as you can see here. And the standards from the W3C for RDF graphs gives you a way to capture that domain expertise in what is known as an ontology. And you can use that to derive new information about your data automatically. Like you can apply these rules and say, okay, this movie is a romantic comedy, so this means it's also a comedy movie. So you can see that this has applications while making recommendations of movies and so on. And this is a standard. Like when on the property graph side, I was saying that the SQL standard is emerging. On the RDF graph side, W3C has had these standards for a number of years now. These are a very mature set of standards. And Oracle Graph has been supporting the RDF graph model pretty much since the W3C standards became available in 2005 or so. And one common use case we see among our customers and other RDF users is that RDF queries gives you an ability to link data from multiple sources. There are constructs within it to make that easy to do. So for example, you have the movie table that I was discussing early in your database. And let's say you have DBPedia, which is information that is not in your movie data, but it's probably relevant to someone asking a query. So the movie table would contain information on Steven Spielberg's movies, the movies he's directed, the revenue that they've generated, and so on. But the movie data table might not contain Steven Spielberg's birth year. And that information is available in DBPedia. So you can write a Sparkle query that says, I want to connect to this particular endpoint. So DBPedia provides what is known as a public Sparkle endpoint that you can query over HTTP. You can send a Sparkle query, get back a result, combine it with a Sparkle query in your database, and say, okay, I want for Steven Spielberg, I'm interested not only in the movies he's directed, but I also want to get his birth year. So I want to get information from two different sources. And that type of application is what our customer, the National Statistics Center of Japan has built. They get in demographic data from different cities, states, and counties. Sometimes they're in different formats. They wanted to link them all together into a unified repository that could be queried. And they found that RDF model was really useful for them to link data at the data level and not at the file level. They want to link the data conceptually. Like these are the number of males in this particular state between the ages of 45 and 55. That's a concept in data that they want to link with similar concepts in data coming from various sources. So they have this really, really large data set that is running on Oracle Graph. and it has scaled very well. A few years ago, they had 1.1 billion triples, and then I think a couple of years ago, they had 2.1 billion triples. And the Sparkle average response time has been constant. This is running on OCI, and it's around average Sparkle response time of 1.27 seconds, and the data set is growing. I believe soon it will be closer to 3 billion, and the query performance has remained constant. And that for especially for RDF queries is quite is an extremely good number. So deployment options. So I talked about Graph Studio. Of course, that's part of the autonomous database deployed in OCI. You could also have your own user managed database in the cloud. We refer to that as a co-managed. You can run your database in OCI. And if you have a user managed database, you could run your databases. The Oracle Graph is available there as well. So Oracle Graph is available everywhere, but all the examples, the performance examples, a lot of that I was showing is in OCI. So to kind of wrap up here, people are looking to find connections in the data, find connections that are not explicit, and detect anomalous patterns in the data. These are the problems that people are looking to address. And there is an opportunity with technology that's available with Oracle Graph on databases running on OCI platform or on user managed systems that really give you a way to easily explore graph technology. And when you're deploying this autonomous database in OCI, you can deploy Oracle Graph in minutes. I mean, you can start up Graph Studio right from your autonomous database console. Makes graph analytics very accessible to folks who are not experts in graph. We have sample notebooks that help you get started. And other reasons why you should do this with Oracle is because of scalability. We have proven to scale to millions and billions and trillions of edges and vertices. And we have support for all the enterprise data management features because it's all part of the Converse database. It is not a separate database where you're moving data into a siloed database just to do graph analytics. You're doing graph analytics within the Oracle database. We have the structures to make this extremely fast. So you have all the enterprise data management features, including ACID compliance, and you can create your graphs from data stored in relational tables. So it's very easy to get started with Oracle Graphs to treat your graph data like any other business data. And you can do this at a very reduced operational cost because, again, you don't have to move your data anywhere. It's part of your Converge database. It's part of your Oracle database. And since this is just part of Oracle, you don't have the risks of starting with a different kind of database. And we always supported standards. We supported the W3C standards for RDF graphs, and now we are planning to support the SQL PGQ standard when it comes up, when it's available for SQL and property graphs. And our notebooks and other tools should make it easy to get started with graphs. And just to, again, close with a few recent new features that to show. So monthly, we update Graph Studio in the autonomous database. And some of the recent new features, property graph views was introduced several months ago, I think a year ago at this point. And we are adding more and more SQL tooling to make it easy to work with graphs. You can also use database functions in your graph query. Like if you have a JSON property value in your graph, you can query that using JSON value functions. We are constantly improving performance. And just recently, we have added, for example, an RDF performance enhancement. We added something that would give 10x performance improvement and so on. So releases, updates are monthly, so you always have access to the latest graph features. And here are some access to some resources. There are some live labs you can get started with, or blogs where my colleagues and I are constantly adding various tips and tricks. We have a YouTube channel and so on. And with that, I think we have a few minutes for questions. Any questions for adding, for I see that my colleagues have been hard at work answering questions. So if there are any other questions, I'm happy to help answer them.
Melly, I am going to launch the third poll.
Sounds good, Esther.
Let me do that. Yeah, while you're completing this poll, again, feel free to enter any questions in the Q&A box. And I just want to make sure that, if you have any additional questions, this is the best time to ask them now. We have the database team here with us, and they'll be more than happy to answer any other questions you have. So ask away.
Right, and we don't have a poll for this, but it would be, since people had already been thinking about graphs, I guess they could post something in the Q&A box as well if they're interested in knowing more. If there's any particular graph topic they wanted to have a deeper dive into, we're happy to do that, because this was an overview, and if folks are interested in knowing more, we're happy to do that. So thank you for going to the poll. I think 47% have participated. If more folks would participate in the poll, that would be great. This really gives us good feedback. And I really like the first one. Are you likely to use graphs in the near future? And looks like a number of people say yes. So please do reach out to us if you want to try out Graph Studio. I think it's a really easy way to get started. And we're here to help.
Exactly. And I just added the email address again of Melly, and also with Hans if you have any follow-up questions, and they'll be more than happy to assist. Are there any questions that you would like to go over, Melly? Want to look at some of the questions that we had?
Yeah, let me do that since we have a few minutes left.
Yeah.
So there's a question here. Maybe I'll just read out that question. Are Graph Studio databases pre-available in the demo cloud instance? So I'm not familiar with what the demo cloud instance is. I wonder whether any of my colleagues are familiar with that. If not, we can take that and get back to the person who asked the question. I will say this, that every time you provision an autonomous database, Graph Studio is available. So if it's a demo cloud instance, perhaps you're referring to the free tier. Yes, Graph Studio is available. And in any demo cloud instance of any database, the graph feature is available. So though I'm not specifically clear on what exactly you mean by the demo cloud instance, I can say that graphs are available for every database. So. Okay, so more clarification that the demo cloud will replace demo central for the demo. So actually we should look into that, but I'm pretty sure graphs are available. If not, reach out to us and we'll take a look at it as well, just to make sure that graphs are indeed there. And let me.
Melly, we had a couple of questions about where to get started, how to get started, and so on. And as you have the link to the live labs here on the slides, I think from my perspective that would be the easiest place to get started and to get your first-hand experience on graph technologies. Esther kindly posted a direct link to one of the graph workshops, which will walk everybody through the fundamentals and how to set things up and how to load data, how to perform queries and run algorithms and the like. So that would be my recommendation. The Live Labs environment, or specifically the one which we were referring to here in the chat, they are also available as sandbox environments. So you don't have any cost or anything. You don't need to use the free tier with a credit card or anything. You can use the Live Labs infrastructure to set up your sandbox environment. It's automatically provisioned and being taken down after I think 4 hours or something. And in these 4 hours, you can try things out, test things, get an idea of how this works. I think that would be the easiest way to walk through some of these topics.
Yeah, you're
Anything for
exactly
you to
right.
add, Melliyal? Yep.
Yeah, you're exactly right. The only thing I was going to add was the demo that I walked through just now. That is available as a live lab. So in the sandbox environment that Hans has talked about, you can do exactly everything that I did. It includes pointers to the data, so you can load the data, create the tables, create the graph, and then run the graph queries and graph algorithms that I was showing as part of the demo. And I agree, Hans, that is the best way, I think, to get started. It's a nice sandbox environment.
Very good. We greatly appreciate everyone's time for joining, and a special thank you to you, Melly, for this presentation. And we have one final poll for you. And if you have any questions afterwards, please feel free to reach out to Melly and to Hans. So let me launch that final poll. All right. Again, join us in the OSI forum, and you can continue the discussions there. And we hope to see you in our next session next Thursday on Helm charts, June 16th, at the same time, 8 a.m. PT. Melly and the database team, thank you for joining us this morning.
Thank you very much for hosting us.
Thank you. Have a good day, everyone.
Thank you. And I hope more of you answer the poll. Thank you very much.